parallelogram law of vector addition. Okay, parallelogram law of vector addition. So basically in that what we do, suppose these are two vectors. Okay, this is your A vector and this is your B vector. So what we do, first we draw a line parallel like this, a line parallel to this A vector and another line parallel to V vector like this, and resultant of the two vectors is given by this line which is passing from the starting point of the two vector. This will be the resultant vector. This will be the resultant vector. Okay, and the magnitude, I have told you vectors have two things. One is the direction, another is the magnitude. So the magnitude of this resultant of two vectors acting at an angle theta is given by magnitude of A vector square plus magnitude of V vector square plus 2AB cos theta. 2AB cos theta. So this is very important formula. This is very important formula. Okay, this is very important formula. Now, for example, if two vectors are given, suppose one force of 3 Newton in this direction and one force of 4 Newton in this direction, and angle between the two forces is 60 degree. Okay, this is one force in this direction, this is another force in this direction, and angle between the two forces is 60 degree, and we have to find the magnitude of the resultant force. We have to find the magnitude of the resultant force. Okay, so we have direct formula to finding the resultant. What is the formula? R is equal to A square plus B square plus 2AB cos theta. Okay, and suppose this is your F1 vector, this is your F2 vector. Okay, and resultant force of F1 plus F2, suppose F. So basically F vector is given by F1 vector plus F2 vector. What is the meaning of this? We are adding the forces vectorically. We are adding the forces vectorically. So what will be the resultant of the force? What will be the under root of F1 square plus F2 square plus 2F1 F2 cos theta, 2F1 F2 cos theta. Now what is the F1 square? 4 square. What is F2 square? 3 square. Okay, so 2 into 4 into 3, what is cos theta? Means cos 60. Okay, so this will become 4 4 is 16, 3 3 is 9, and this will become 4 2 is 8, 8 3 is 24. Okay, this is 24 into cos 60 is 1 by 2. Cos 60 is 1 by, this will become 12. So this will become root 37. So basically this, what is this F? What is this F? This F is the magnitude of the resultant of F1 and F2 acting at angle 60 degree. Okay. Now for this resultant R, if you want to find the direction, suppose this resultant is making an angle of beta. This resultant is making an angle of beta. Then direction you can find with the help of this formula. tan of beta is equal to b sine theta divided by a plus b cos theta for the direction, and this angle beta is representing the direction of the resultant vector. So basically magnitude from here we will get from this formula, and direction we will get from this formula, because this beta is an angle. Okay, so angle, suppose this is the initial angle, now angle change, direction change, angle change, direction change. So this beta and tan beta is representing, or you can say this beta is representing the direction. Beta is representing the direction. Okay, so here if you want to find the direction of the resultant in this case, so what you have to do, the resultant will be like this. So resultant vector will be like something like this. This will be the resultant vector. Resultant vector will be like this. Okay, and this resultant vector is equal to, I have assumed that this is a force vector. So this force F is equal to F1 plus F2. Basically this is the magnitude of the force. For the direction, what we will do, we will find this beta. We will find this beta. So we will find tan beta. What is the formula of the tan beta? B sine theta divided by A plus B cos theta. So tan beta, what is B here? You can take B, this vector as B vector. This is B and this is A. Consider this as A. Okay. So your B is 4 Newton, B is 4 Newton and A is 3 Newton. Okay. So what is your A and B? B is 4 Newton and A is 3 Newton. Now tan beta is equal to B sine theta. B means 4. Sine theta means sine 60. A plus B cos theta. What is A? A is 3. 3 plus B cos theta. B cos theta means 4 cos 60. Now solve it. 4 sine 60 means root 3 by 2. And this is 3 plus 4 into cos 60. Cos 60 means 1 by 2. So basically it will become 2 root 3. 2 root 3 divided by, this is 2 to the 4. 2 root 3 by 5. So your tan beta is equal to 2 root 3 by 5. Tan beta is equal to 2 root 3 by 5. So what you will get? Beta is equal to tan inverse 2 under root 3 by 5. And tell me, Shafuddin, what is beta indicating? This beta is indicating the direction. Okay, this beta is indicating the direction. And magnitude, this is the magnitude of the force, this is the direction of the force. And for defining the vector, two things are required: direction as well as the magnitude. Got it?
Yes, sir.
Now we will discuss the special cases, and that special cases are very, very important. Okay, we will use that special cases many times. Okay, so focus on the screen. Special cases. Special cases. Okay. Number one, when two vectors are parallel, what we are doing, we are just calculating the resultant of two vectors. Suppose one vector is this and another vector is this, acting at a point. We want the resultant vector or the vector addition. Okay, so when two vectors are parallel, two vectors are parallel. Two vectors are parallel means what is the angle between the vectors when two vectors are parallel? This is one vector. Suppose this is your A vector. And this is your another vector. Suppose this is your B vector. Now, what is the angle between A and B? Shafruddin?
Yes, they both will be the same, right?
Hmm.
No, B is greater than A.
No. Actually, basically, this is the A vector and this is the B vector. I'm not asking which one is greater. I'm asking what will be the angle between A vector and B vector. 0 degree,
Right?
na? 0,
Yeah.
because both are acting in the same direction. So angle between the two vectors is equal to 0 degree. Now we can find the resultant of A and B. So what is the formula of the resultant? A square B square plus 2AB cos theta. Now, and what is A? Basically, A is the magnitude of A vector. What is B? B is the magnitude of B vector. Okay. So you can write here A square plus B square plus 2AB cos 0. What is the value of cos 0? Cos 0 is equal to 1. So you will get this under root of A square plus B square plus 2AB. And this will become A plus B square. And finally, you will get the resultant A plus B. This is very, very important. Means if two vectors are acting in same direction, the resultant can be found by simply adding those two vectors. For example, this is a point. At this point, one force of 5 Newton is acting in this direction and another force of 3 Newton is acting in this direction. If I am asking what is the resultant force, on this body or particle, suppose this is any particle, what will be the resultant force on this particle? Here are two vectors and two vectors are acting in same direction. What is the resultant? Suppose resultant is F, resultant force is F. How you will calculate? One vector plus another vector
Yeah,
means 8 Newton force will be there. 8 Newton force will be there on the particle. Okay. Second case, when two vectors are anti-parallel. Means one vector is in this direction, another vector is in this direction. Suppose this is your A vector and this is your V vector. So in that case, what you will do? You will take the resultant like this. You will subtract. You will take the resultant. Either you can calculate by using this formula A square plus B square plus 2AB cos theta. Theta will become 180, and when it will become 180, so your finally in under root you will get A square plus B square minus 2AB, and that will be equal to A minus B whole square. So finally the resultant you will get is equal to A minus B. Okay. Basically you will get A minus B. Okay. So here resultant you will get simply A minus B. If two vectors are at 180-degree angle or anti-parallel to each other.
yeah.
Okay, now for example, this is any particle, and on this particle, one force is acting in this direction of 2 Newton, another force is acting on this particle 3 Newton. Can you tell me what is the resultant force? What is the resultant force on this particle?
2 minus 3 or 3 minus 2, sir?
We will write 3 minus 2. First, greater minus smaller. Okay. So
Okay.
resultant force will be 3 minus 2. That is 1 Newton.
So,
Okay.
sir, in
1
any
Newton.
case, you need to take only the greater one.
Yeah. We will subtract smaller value from the greater value.
Okay.
Okay. And direction, remember, direction of resultant force. If someone is asking what will be the direction of the resultant force, direction of the resultant force will be direction along the 3 Newton. So this will be the resultant direction. Okay, this will be the resultant direction. If you are subtracting 3 minus 2, then resultant direction will be direction of 3 Newton force. Here, if I am talking about the direction, then what will be the direction? Direction will be, direction of the resultant force will be in this direction. Okay, this will be the direction of the resultant force. Here, this will be the direction of the resultant force. Okay, now third case that we have discussed, that I have told you the tangential acceleration and the centripetal acceleration are perpendicular. This case we will discuss here, means in vector. Two vectors are perpendicular. Two vectors are perpendicular. Perpendicular means, suppose these are two vectors like this. This is a point. A vector suppose is in this direction. This is one vector, and this is the another vector. This is B vector. And angle between the two vectors 90 degree, means theta is equal to 90 degree. Two vectors are acting at 90 degree angle, and we want the resultant vector. We want the resultant vector. How to write the resultant vector? R vector is equal to A vector plus B vector. Now resultant can be found with the help of this formula. R is equal to under root of A square plus B square plus 2AB cos theta. Okay. So now A square plus B square plus 2AB cos 90, because theta is 90 and cos 90 is 0. Cos 90 is 0, so this whole term will become 0. So basically the resultant you will have simply A square plus B square. That is why there I have told you that. We will write tangential acceleration square plus centripetal acceleration square under root for the resultant acceleration. See, that was the case. I have told you in a circular path. Suppose here I am considering one point and this is a center. So I have told you in this direction there will be the tangential acceleration. This is the tangential acceleration, and in this direction there will be the centripetal acceleration. Told you or not? Centripetal acceleration v square by r. Tangential acceleration dv by dt. I have told you na. And see here what was the case here? Two vectors acting at, because acceleration I have told you is a vector quantity. Acceleration is a vector quantity na. So here two vectors are acting at 90 degree angle. Then resultant we can find, resultant of these we can find, suppose net acceleration is the resultant acceleration. So magnitude of net acceleration, there I have written under root of a square plus b square. A square plus b square means one vector square plus another vector square. Okay, so at square plus ac square. There I have written now. So this was the case of the vector. From this formula that was driven. Got it? And if you want to find the direction now, suppose this is the resultant vector. This is the resultant vector you are getting. And if you want to find this theta, then tan theta you can find with v sin theta divided by a plus v cos theta. What is v sin theta? V sin 90 divided by A plus B cos 90. So cos 90 becomes 0 and sin 90 becomes 1. So your tan theta is equal to B by A. Tan theta is equal to B by A. And there what I have told you for the direction of this acceleration. What I have told you for the direction of the acceleration. Suppose this is making an angle of alpha. So there I have told you tan alpha is given by B by A. This time this becomes B vector AC by AT. AC by AT. Now the picture clear?
Yes. Can I take a picture now?
Yes.
Done, sir.
Okay.
Done, sir. Done, sir. Done, sir. Done, sir. Done.
Done. Okay.
Done, sir.
So that is why I was saying there is a requirement of vector for the further study. Completed? Okay, so this is the main part, and there is one more part that will be required. Resolution of vector. Resolution of vectors. See, resolution of vector. For example, what is okay? So resolution of vector.
Sir, can you hear my voice?
Yeah. Is there any problem?
No, because it showed that my internet connection is unstable.
Now your voice is okay. No problem. Voice is
Okay,
okay.
sir.
Okay. So suppose this is your x-axis. This is your y-axis. This is your x-axis. This is your y-axis, and there is one vector like this. This is one vector. Suppose this is your a vector. So this vector A is making an angle theta with x-axis. Now resolution of vector means we will see the effect of this vector along x-axis and along y-axis. For example, I am explaining this with the help of the example. For example,
Sir, 1 minute, sir. I want to change my Wi-Fi because my internet is very
okay. You can rejoin the meeting if you want. You can just fix this. Okay, no problem. Okay.
So can you hear me now?
Now I can hear you.
Okay.
Now all good.
Yes, sir.
Okay, so now focus. So suppose this force is acting. Are you able to understand what I want to say? Means what I am saying here. Force is acting like this, and this is the we are representing the force in the form of the vector because force is a vector quantity. Okay. Hello. Your voice is not.
Yes, sir.
Uh, are you able to listen me?
Yeah, yes, sir.
Okay. So this is the force vector, and this force vector is acting at angle theta with x-axis. Now component of the vector means we want to see the effect of this force along x-axis and along y-axis, so we can just resolve it along this direction. This component will be f cos theta, and along this direction this component will be f sin theta. So basically two new vectors we got. One vector is this vector f cos theta. So this is suppose force along x, effect of force along x, and this is effect of force along y axis. Very important part. So basically we can just resolve any vector along axis, x axis and y axis. So here this becomes a cos theta. This will be component of a along x axis, and this will become a sin theta, that is a component of a along y axis, that is a sin theta. A sin theta. Okay. There can be one more case also. For example, if two vectors are, this is your y axis and this is your x-axis. And here is one vector, and this is the vector, okay? And this vector is making an angle theta with y-axis this time. So now we want to resolve this vector. Suppose this is a vector. We want to resolve this vector along y-axis or along x-axis. Okay, so what we will do? Now this a vector is making an angle theta with the y-axis, na? So what we will do, along the y-axis, the component of the vector becomes a cos theta, and along the x-axis, the component of the vector will become a sin theta. So remember these points. Remember these points. Okay, there is one more case. Shafruddin, just wait for a minute. Okay, so suppose this is a inclined plane. This is the inclined plane. On this inclined plane, suppose a block is placed. A block is placed on this inclined plane. So talking about the weight of this inclined plane, the weight of the inclined plane always, weight always acts toward the center of the earth downwards. So weight will be like this. This will be the weight. What is the weight? Mass of this block into acceleration due to gravity. Now in this case, now, if we want to take the components, then what we will do? In this case, we will take two axes. We will choose. First axis perpendicular to the plane, and second axis parallel to the plane. Two axes we will take, and we will consider this axis as x-axis and this axis as y-axis. We can choose the axis according to our needs. Okay, so now I have considered this as x-axis, this as y-axis. So I want to resolve this. This is weight, and weight basically is a force. Weight is basically a force, and we want to resolve this weight along the plane and perpendicular to the plane. Okay, so this angle is theta. Hello, Shafruddin.
Yes, sir.
Getting now?
Yes.
This block has the weight acting in downward direction, and this is the inclined plane. This is angle theta. Now we want to resolve this force. This is basically a force. Weight is basically a force, and I want to resolve this force along y-axis and along x-axis. And now this time we have taken the axis, one parallel to the inclined plane and perpendicular to the surface of the inclined plane. Now see, this angle will be 90 degree. So we can say this angle will be 90 minus theta. This angle will be 90 minus theta. So we can say this angle will be theta. This angle will be theta. Now, if we want to take the component, then we can say that in this direction, what will be the component of mg? What will be the component of mg? See here, see here. This is the vector. This is the vector, and with this axis, this vector is making an angle theta, and along this axis, what is the component? A cos theta. A cos theta. Now tell me what will be the component along this axis? Just try. Apply
Sin
your
theta,
mind.
right?
No. Cos theta. Cos theta. See here. See here. This is the force now. This is the force. And along this axis, this force is making an angle theta. So along this axis, the component will be cos theta of that force. F cos theta. So here also, this is basically a force. This is a gravitational force. And this force is making an angle theta with this axis. So what is the component along this axis? Mg cos theta.
Mg cos theta.
Okay. Now this is the vector. So I have just resolved this vector along this axis. Now along this axis, tell me what will be the component.
Mg sin theta.
Very good, very good. Mg sin theta. Mg sin theta. This is very important. Very, very important. Okay, so now we will discuss the multiplication of the vectors. Multiplication of the vectors. When we will discuss the rotational motion, there multiplication of vector will be required. Cross product will be required. Basically, multiplication of the vectors, we can say suppose it is written that a vector is given. Suppose force vector is given. Okay, force vector is given like I cap plus j cap plus 2 times of k cap, and I want to multiply this force vector with an scalar, that is 2. I want to multiply this vector with scalar. So multiplication with scalar. Number, you can say number. Suppose I have multiplied 2 with f. So resultant vector will be multiplied with 2. This will be I cap plus j cap plus 2k cap. Finally, it will become 2i cap plus 2j cap plus 4k cap. Okay, now we will discuss one scalar product. Scalar product. Scalar product. So what is the meaning of the scalar product? For example, if you have two vectors, suppose this is your one vector A vector and this is your another vector B vector. Both of these vectors are at angle theta. This is your A vector and this is your B vector. Now scalar product means this scalar product is also known as the vector product, cross dot product. This is also known as the dot product. Dot product. So dot product means you will write a vector dot v vector, and this dot product of the vector is given by magnitude of a vector, magnitude of v vector, and cos theta. Okay, magnitude. What is the meaning of the magnitude of the a vector? Magnitude of the a vector is, we write like this, na? Magnitude of the v vector, we write like this. Magnitude of v. So a b cos theta. So basically, a is a scalar. A will be a number. A will be any other quantity. A b cos theta. Basically, result you will get scalar. So result of the scalar product will be scalar. That is why this is known as the scalar product. Result is scalar. Result is scalar. For example, uh, work done. Suppose I am representing work done with W. Basically, work is a scalar quantity. So work done is given by the dot product of force and the displacement vector. Dot product of force and displacement vector. For example, power. Power is also a scalar. So power is given by the dot product of force and velocity. So that is why we are learning this scalar product. There will be a requirement of this. Okay. Okay, so now properties, we will discuss properties of dot product. First property, A dot B will be equal to B dot A. Will be equal to B dot A. This is known as commutative property. Okay, A dot B and B dot A will be equal. Suppose two vectors are parallel. This is A vector. Suppose this is the B vector. Parallel vector. What is the angle between the parallel vectors, Shafruddin? What is the angle? What is the angle between the parallel vectors? Parallel vectors?
Zero, right? Because it's straight.
Zero degree. So if you want to find the dot product of parallel vectors, that is A vector, B vector, what is the formula of the dot product? AB cos theta. So you will write here AB, and this is cos 0. Cos 0 is 1, so finally you will get AB. And when two vectors are parallel, then dot product become maximum. Okay, so dot product become maximum. Why? Because cos theta becomes maximum. So dot product become maximum. Becomes maximum. I have told you what is. I have told you about the unit vectors now. That is I cap, J cap, and K cap. I have told you now. Means three axes are there: x axis, y axis, and z axis. X axis, y axis, z axis. This is I cap, J cap, and K cap. What are they? I cap, J cap, and K cap are the unit vectors along x axis, y axis, and z axis. I have told you. Now, if you want to write the dot product of I dot J or J dot K or K dot I, then how you will get? So suppose you want to write the dot product of I cap dot j cap dot product. How to write the dot product? Magnitude of I cap, magnitude of j cap, and cos theta. What is theta? Theta is the angle between I cap and j cap. What is the magnitude of I cap? I cap is a unit vector, na? Magnitude is 1. What is the magnitude of j cap? J cap is also a unit vector, so magnitude is 1. What is the angle between I cap and j cap? I cap and j cap angle is 90 degree, and cos 90 is 0. So that is why I cap dot j cap is equal to 0. Similarly, you can say j cap dot k cap also is equal to 0. Similarly, you can say I cap dot k cap is equal to 0. Similarly, you can say, okay, all the I j, j k, k I, all the vectors, unit vectors dot product will be 0. Okay. For example, if you want to find I cap dot I cap, then what you will write? Magnitude of I cap, magnitude of I cap, and cos of theta. What is the angle between I cap and I cap itself? Shafruddin, what will be the angle between the I cap and I cap itself?
0 again.
0 degree, 0 degree. This will here will be cos 0. So this is 1, this is 1, and cos 0 is also 1. So I cap dot I cap you will get 1. Similarly, I cap dot I cap you will get 1. J cap dot J cap you will get 1. K cap dot K cap you will get 1. And if it is written as minus I cap dot I cap, so it will be minus 1. If it is minus I cap dot minus I cap, then it will be 1. So remember these points. Third property. Suppose two vectors are perpendicular. A vector, actually we have discussed this case here. Here the two j cap, I cap, and k cap are the perpendicular vectors, na? So we have discussed this. Okay, so note down. Then completed. Done. Okay. Done. Okay. Okay. So now we will discuss dot product in Cartesian form. Basically, very easy concept. Cartesian form. What I have told you about the Cartesian form, suppose a vector is given as 2 I cap. We write the vectors in terms of the unit vector, that is known as the Cartesian form. I cap plus 3 j cap, okay, plus k cap, and v vector is I cap plus j cap plus k cap. If you want to write a dot b, na, dot product of a b, if you want to write, then what you will do now, you will multiply this 2 with coefficient of I cap. Okay, what is coefficient of I cap here? Hmm?
2.
No, here I am asking here.
Oh, so that is 1.
1. So you will multiply 2 with 1, so it will become 2. Here you will multiply 3 with 1, it will become 3. Here you will multiply 1 with 1, it will become 1. So finally what answer you will get? 6. Okay. Okay, so one question I am giving. Suppose P vector is I cap minus J cap plus 2K cap, and Q vector is given as 2I cap plus 3J cap minus of K cap. You have to tell me the answer of P vector and Q vector. Apply the simple concept that I have told you and just find the value and tell me the answer. Try it by yourself.
So I'm getting -3.
-3. Okay. Just check your answer. I am solving. Okay, check your answer. So basically, you will multiply 1 with 2. Coefficient of I cap is 1 and this is 2. So here it will be 2, and here is minus 1 and 3. So it will become -3. Here is 2 and minus 1. So it will become -2. Very good. -3. Very good, Shafuddin. Very good. Well done. So means basically now why I am teaching this? Why I am teaching this? Because if somewhere someone is asking that calculate the work done if force vector is given as 2I cap and displacement vector is given as 3I cap. Then if someone is asking calculate the work done, then work done is given as dot product of F dot S vector. Then in that case, this concept will be required. Okay, so how we will calculate? 2I cap into 3I cap will become 3 to the 6 joule. Got it now? Why we are just discussing the vectors? Because there will be a requirement of the vector when we will study the work. Basically, after this, we will discuss the cross product, and cross product we will use when we will study the torque, when we will use when we will study the angular momentum. So then there will be a requirement of those things. Okay.
Okay.
So don't think that it is just wastage of time. It is not the wastage of time, because vector will be used throughout the physics. Vector will be used throughout the physics. Okay.
Okay.
And in your school, which chapter is going on?
So in school, they'll start the new chapter after 2 weeks only. They're starting new chapter, I think November 21st.
So now, currently, which chapter is going on?
Currently, we are still doing AS level revision.
The AS level division I know, but with name of the chapter, name of the topic, do you know?
No, sir, we just take random past year papers and do so.
Okay. So what you should do now? Do you have my number now? So
Uh,
if you have the papers, then send me at least 2 papers, past year's papers. Okay.
you want me to send the link or the papers?
Whatever you like, means whatever you want.
Yeah.
Just okay. So just try to send me those papers. Uh, then okay. So Shafruddin, that's all for today, and revise your notes properly. Eh, Okay. And after that, after completing the this small portion or introduction of the vector, because I am just telling you the basics of the vector. I am not going in detail. In detail, this chapter takes at least 10 lectures. Okay, in 10 or 8 lectures it will take, but we will complete it in within 3 lectures. So in next lecture, I think half of the lecture, I think I will try to finish it.